Hi there. In this video, I just want to talk to you about an introduction to the VSEPR theory. And we're going to use this VSEPR theory that stands for valence shell electron pair repulsion. So we're going to be talking about valence electrons and how they determine what the shape of a molecule is about. So we can see here, and you're going to have a copy of this, so hopefully you have found that and are looking at it. Valence electrons arrange themselves around a central atom in a molecule or polyatomic ion so as to maximize distance between them. Remember that those electron pairs are negative, so those charges repel each other, and they determine what the molecular geometry is. So this is a process, and it's not something that is a one-step thing. You have to go through each step to learn. Eventually, you should be able to get to the point where you can look at a formula and maybe relate it to one you've seen before and be able to make a quicker decision. But right now, we're at the beginning. So we're going to always start by drawing a Lewis structure for whatever we're studying. And then from that drawing, we're going to determine how many regions of electrons are around a center atom. Now, a region of electrons could be a single bond, could be a double bond, could be a triple bond, or it could be a pair of non-bonding electrons. So we have to pay attention to those as well. So for the electron geometry, we count up how many regions of electrons are around the center atom. And if there are two, then they arrange themselves 180 degrees apart, and we have a linear arrangement. And so we can imagine something like this. A center atom, we have two regions of electron density. Maybe these are double bonds, maybe they're single bonds, whatever they might be. But this center atom has two regions of electron density around it, and they arrange themselves as far apart as they can be from each other, which is 180 degrees, and we call that a linear arrangement. If there are three regions of electron density, well, that would be a situation, again, I'm just using generic things here, but maybe we have something like this. Maybe there's X with three regions like this, two single bonds and one double bond. That still counts as three regions of electron density. This counts as one, even though there's a double bond there, it still just counts as one. So I have three regions of electron density. And when that happens, they arrange themselves as far apart as possible. That would be 120 degrees apart. And the name for this shape is trigonal planar. Trigonal because we can see there's kind of a triangular shape here, and planar because it'd be a flat molecule. They'd all be in the same plane. And I bet you can see why. If this Y was bent out of the plane, then it would be closer than it needs to be to these other Y's. So keeping them all in one plane keeps them as far apart as possible, which is the whole idea behind this. Most common, though, we're going to see where we have four regions of electron density. So in that, for an example, I would draw something like this. And I've got four regions of electron density. They actually arrange themselves in a tetrahedral shape, and it's hard for me to draw it on the paper adequately, so I've made a model here to show you. So can you see, if we look at it right from the top like that this atom, and the center atom are all in one plane, and then one is coming toward me, and then one is going away from me in that plane. So that's a tetrahedral shape, 109.5 degrees apart. The next video will be about molecular geometry.